Hi folks, welcome back to Sourced by Cofactr, the show that cuts through the noise and gets to the good parts. I'm Ed Dodd, great to have you joining me. I'm assuming you're an electronics manufacturer. You have just poured capital into raw materials. We're talking high-end microprocessors, specialized capacitors, maybe some custom wiring harnesses. A lot of these components are probably supply constrained. So you take all of those precious components, run them through the assembly line, and build, 1,000 units of a specific finished product. But here's the kicker. It turns out you built more than current demand. You can probably see where this is going right now. They are just sitting on a warehouse shelf, gathering dust and tying up working capital. The real agony, the real pain, begins when the market shifts. Because while those finished goods are just sitting there, taking up space, real customer orders start pouring in. But they're for a slightly different product that uses the exact same microprocessors and capacitors. So you can't fulfill these orders because the components are permanently trapped inside the wrong finished products. You're watching your capital sit there stranded while actively leaving revenue on the table. It's a bummer, and it's happened to all of us. So today, I want to explore a supply chain strategy engineered to prevent this. It's called Build to Order, or BTO. It's an important planning method to understand. But to really grasp how this works, we need to understand its academic backbone. Build to Order relies on a concept called postponement, or delayed differentiation. This principle was introduced decades ago by a pioneer named R.O. Alderson, and the core philosophy is brilliantly simple. You keep your optionality upstream, and you delay your final commitment until market demand is absolute. I love that. Delay your final commitment. So today we're going to talk about how holding back your final commitment can actually be the fastest way to move your operation forward. It's counterintuitive, but it works. But before we can use BTO to rescue that stranded capital we talked about, we have to establish what it actually is, because the term gets thrown around a lot in the manufacturing world, often incorrectly. BTO kitting operates on a very precise mechanism. It means that the structure of the kit, like the exact bill of materials, is logically defined in your systems well in advance, so the recipe is locked in. However, the physical assembly of that kit only happens after a valid, explicit trigger occurs. A trigger being something like a locked-in production schedule, or a customer actually hitting the buy button on a website. Until that explicit trigger happens, the raw goods are simply not touched. To really frame this, it helps to contrast it with what it is not. Take build-to-stock. That's a scenario I opened with. You pre-build to a sales forecast before the real orders materialize. You cross your fingers and just hope the forecast was right. Sound familiar? This is actually a vulnerability, especially in electronics where component costs are high and availability is constantly shifting. Another method I see often confused with BTO is simple pick and pack. People mix those up all the time, but pick and pack is essentially throwing multiple loose items into a shipping box, like an Amazon order. It's not usually a structured kit. And then there is full configure-to-order manufacturing. This is very easy to conflate with build-to-order. Configure-to-order relies on a highly complex rules engine. It essentially designs the product on the fly based on customer selections, so the bill of materials is actually dynamic. Build-to-order, on the other hand, relies on fixed or semi-fixed bills of materials. The payoff for understanding and implementing BTO can be really significant because it dramatically lowers your exposure to stranding raw material in slow-moving finished goods. BTO is kind of like running a sandwich shop. If you pre-make 100 turkey and provolone sandwiches before you even open the doors for the day, that is built to stock. And if the lunch crowd suddenly walks in and they all decide they want ham and provolone, well, you have a lot of bread and provolone stranded with that turkey. BTO keeps the bread, meat, and cheese totally separate. You are pooling your core ingredients and you're waiting to actually assemble the final product until the waiter hands you the physical ticket. That is a perfect analogy because it highlights the whole concept of component pooling. Keeping the bread, meat, and cheese separate until the order drops allows the shop to offer a really high variety of sandwiches without carrying the financial burden of pre-made inventory. This can just make so much sense in the electronics manufacturing, where demand is very hard to forecast accurately. Customers demand responsiveness, and operations teams are under intense pressure to deliver faster. So, postponement is really the only way to achieve that without flooding the company in inventory holding costs. That makes the financial logic completely undeniable. But if keeping the bread, meat, and cheese separate solves all these capital problems, why is it so rare to see a facility actually execute this flawlessly? There has to be a catch. There's always a catch. The reason is postponement doesn't just make supply chain complexity magically disappear into thin air. Far from it. The complexity doesn't disappear at all, it relocates. Executives often see the financial benefits of lowering finished goods inventory, and they assume they have found a silver bullet. But BTO simply takes the complexity of inventory forecasting and shoves it directly onto the physical execution layer. So your inventory risk shifts downward toward the individual components, while your execution risk shifts outward toward the actual tight window of fulfillment. Let me challenge this for a second, because that sounds terrible. Are we saying we are not actually eliminating the stress of manufacturing, but rather condensing all of it into a microscopic, high stakes window right before a truck leaves the dock? That sounds less like a strategy and more like trading an inventory problem for a daily panic attack. That is precisely what happens if you treat this purely as an accounting trick. If you lower your finished goods inventory to free up capital, but fail to upgrade the warehouse floor's capability to assemble on demand, you will absolutely induce a panic attack. And the reality of that breakdown on the warehouse floor is pure chaos. You get component shortages appearing at the exact moment a kit is released for assembly, which is the worst time to find out you're short. You get miskits that are not discovered until the floor actually opens the box. And then you have frantic, expensive expediting happening just to recover from what were essentially completely avoidable misses, and a lot of tense emails that nobody enjoys reading. The unforgiving truth of BTO is one single missing component makes an entire work order unavailable. If a kit requires 50 distinct parts and you have 49 of them in perfect quantities, you don't have a kit, you just have a pile of parts. You have a pile of useless parts. Which brings us to a really critical juncture. If that execution window is so tight and the margin for error is basically zero, because 49 out of 50 parts equals zero revenue, how does a manufacturer survive that pressure without constant panic? You survive by building an incredibly rigid, highly reliable operational foundation. There is no faking it. You cannot fake your way through build to order. So what does that foundation look like? It starts with the absolute integrity of your master data. You need strictly controlled bills of materials, or BOMs. You need tight revision control. You need governed item attributes and correct units of measure. All of it has to be flawless. But having a perfect recipe, a perfect BOM, is completely useless if you go to the pantry and your ingredients are missing. Which brings us to the human element on the warehouse floor. If a facility has bad data, and the system says one thing, but the physical build requires something else, the operators on the floor are going to improvise just to keep things moving. And that improvisation can be the single biggest threat to a BTO operation, hands down. Really, the biggest threat? Yes, because it destroys repeatability, and BTO kitting relies entirely on repeatability at speed. I want to dig into that because it sounds like improvisation is the enemy here. If substitutions are handled through tribal knowledge and random Slack messages, you do not have a BTO system. You just have a recurring argument. Why is human improvisation so incredibly dangerous in this specific environment? Let's say a worker is missing a specific specialized screw for an assembly, so they just grab a slightly different one from another bin because they know from experience that it fits just fine. They solve the problem, the kit gets built, the customer gets their order. Why is that bad? Because they just planted a landmine for tomorrow. Yes, they solved the immediate problem for that one specific kit, but they have just corrupted the inventory accuracy for both the screw they were supposed to use and the screw they actually took. The system still thinks the original screw is in the bin, and it thinks the stolen screw is available for a future order. So when the system later tries to build a different kit that legitimately needs the screw they stole, the worker goes to the bin and it's empty. Improvisation has broken the chain of data, which means high inventory accuracy is not just some vanity goal to make managers feel good. It's the oxygen of a BTO operation. It really is. You need real-time visibility into what is actually available to use, not just what technically shows as on-hand in the system, because on-hand might include parts that are damaged, parts that are quarantined for quality checks, or even parts already silently allocated to a different order. And governing all of that requires real-time systems. You cannot manage a fast-moving, delayed differentiation model with static documents. So no spreadsheets. Heavy reliance on spreadsheets is a massive warning sign. By the time someone updates a spreadsheet, the physical reality on the warehouse floor has already changed. Let's look closer at the software side of this, because I think a lot of people get confused here. A manufacturer might say, look, I have an ERP, an enterprise resource planning system that handles my inventory. Why on earth do I need a separate warehouse management system, a WMS, and an order management system, an OMS? How do these systems actually interact in that split-second window when an order finally drops? That's a very common point of friction. Think of them as having distinct jurisdictions. The order management system, the OMS, handles the customer promise. It captures the demand and decides where the order should be routed. The ERP holds the master recipe, the BOM, and the financial reality of the business. But, and this is crucial, the ERP is not built to orchestrate the physical movement of a human being walking down an aisle. It does not know where the bins physically are. That is a jurisdiction of the warehouse management system, the WMS. So the OMS catches the order, checks the ERP for the recipe, and then hands it to the WMS to actually execute the physical steps. The WMS breaks that order down into interleaved tasks. It tells the worker exactly which path to walk, which bin to pick from, and in what sequence. If those three systems are not communicating in real time, your execution window just collapses. So the systems are talking. The data is clean. The worker walks to the bin. What happens when a mistake actually happens during the pick? Because humans still make mistakes. Traditional manufacturing relies really heavily on final inspection. You build a product, it gets to the end of the line, and a quality control inspector signs off. And here is a fatal flaw with traditional quality control in a BTO environment. Final inspection is simply too late. If you wait until a complex electronic assembly is completely assembled to check it and you find a mistake, say the wrong capacitor was used deep inside the housing, you have to tear the entire thing apart. That is incredibly wasteful. So how do you catch the error before the assembly happens? You shift quality control into the workflow itself. You build scan-based confirmations directly into the picking process. So as the operator is picking the parts for the kit, they are scanning the barcode on the bin or scanning the part itself. The WMS instantly verifies whether it is a correct component for that specific BOM. So the system will not let them pick the wrong part. And in regulated industries like medical devices or aerospace, the worker might also be prompted to capture a lot or serial number right there in real time. The quality check happens inside the process, stroke by stroke, not at the very end of it. So we've mapped out the problem of stranded capital, the mechanism of postponement, the catch of execution risk, and the foundation required to survive it. If you are an electronics manufacturer listening to this, you might be feeling a mix of excitement about the capital savings, but also serious dread about the operational rigor required. It is a lot to take on. So should you march into the office tomorrow, flip a switch, and move your entire operation to BTO? Absolutely not. Please do not do that. Flipping the switch overnight is a guaranteed disaster. The most mature, successful operations take a highly segmented approach. They look at their product catalog and realize, honestly, not everything deserves the BTO treatment. So if flipping the switch is a disaster, how do you even choose what product to test this on? Where does BTO kitting actually fit best? It is a remarkably strong fit for high variability kits that share a large number of common components across many different variants, like the sandwich shop. Lots of sandwiches, same basic ingredients. On the flip side, it is a terrible fit if your demand is highly stable. Why? Because if you know with absolute certainty that you are going to sell 5,000 identical units every single month, just pre-build them. Efficiency wins there. Why add the stress? Don't complicate what's already predictable. It is also a bad fit if your promised ship times to the customer are extremely short, so short that you physically do not have time to run the assembly process after the order drops. If the customer expects it shipped in 2 hours, you cannot be scrambling to allocate parts and build it from scratch. The math simply does not work. So, walk through a hypothetical. An operations director wants to try this. What does day one of a sane implementation actually look like? You start with a narrow pilot. You select the specific family of kids where component commonality is high and the service promises are realistic. Start small, very small. First, you lock down the BOM data. You scrub it relentlessly so there is zero ambiguity. Then, you physically count and validate the component inventory for those specific parts on the shelf. No guessing. And then you design your operational workflows for the exceptions, not just the happy path. What exactly happens when a worker encounters a shortage? Who do they alert? How is it documented in the system? You have to plan for the breakdowns. So you pilot it narrowly and you do not expand until the process becomes, frankly, boring. No frantic expediting, no warehouse panic attacks, just a predictable, highly controlled machine. That is the dream state. Boring is good. But to know if it is actually running smoothly, you have to measure it. And this is where I think companies often lie to themselves with metrics. Vanity metrics are incredibly dangerous in a BTO environment. A dashboard that only shows your output volume, like how many kits you pushed out the door this week, can be deeply misleading. A green dashboard showing high output volume is exactly how bad broken processes get promoted. Because output volume tells you nothing about the collateral damage it took to get there. An operation could hit its output goal, but behind the scenes, they might be working massive amounts of overtime, cannibalizing other orders just to find parts, and paying exorbitant overnight shipping fees to compensate for a workflow that constantly falls behind. To really understand your BTO health, you must measure things that reveal cause and effect. You need to measure first pass yield, meaning how often a kit gets built perfectly the first time without needing to be torn down and reworked. You need to measure expedite frequency. Are you constantly putting out fires? Metrics like these tell you the truth about your operational foundation. Let's put this on the spot for a moment to crystallize it. If you are an operations leader listening to this and you are tempted to start a pilot next week, what is the single biggest red flag in your current operation that should tell you you are absolutely not ready for BTO kitting? The single biggest red flag is a reliance on institutional memory. If Bob on the warehouse floor is the only person who knows that part A can actually be substituted for part B, and that rule is not strictly documented and locked into your ERP system, you are not ready. Also, if your routine cycle counts consistently show that what your software thinks you have is wildly different from what is actually sitting on the physical shelf, you are not ready. It's like trying to navigate rush hour traffic using a map drawn 10 years ago. You can drive as fast as you want, and your engine can be incredibly powerful, but your underlying data practically guarantees you're going to end up in the wrong place or crash entirely. That is a much more accurate way to look at it. BTO kitting will not fix a broken inventory system. It acts as a magnifying glass. It will expose those weaknesses immediately and catastrophically because there is no buffer of finished goods to hide behind anymore. You must fix the map before you accelerate the car. Let's bring this all together. Build to order is clearly far more than just a clever warehouse trick to make the balance sheet look better for a quarter. It is a highly practical, incredibly powerful application of postponement. It creates massive value by keeping your capital flexible and your materials uncommitted until demand is actually certain. But as we've learned, it only works for manufacturers who have the rigorous execution discipline to support it. It's all about delaying your final commitment without losing control of the process. And for electronics teams out there who are evaluating this, who are looking for help with the heavy lifting of sourcing negotiations, storage, kitting, and delivery, you might explore platforms like Cofactr to handle those logistics while your team stays focused on actually designing great products. The underlying principle here is truly profound when you step back from the warehouse floor and the supply chain software. We've seen how postponement saves manufacturers from stranding their physical capital. But think about your own daily workflows, your team's long term projects, or even your personal life. Where are you currently committing your time, energy, or resources way too early? And what raw materials of your own are you needlessly stranding as a result? That is a fantastic question to leave you with because nobody wants their best resources, whether it is custom microprocessors or just your own time and energy, locked away on a dusty shelf, unable to be used when the real demand finally arrives. Keep your options open, build a rigorous foundation, and commit when it counts. Thank you all for joining me on Sourced by Cofactr. I'm Ed Dodd. I hope we cut through some noise and helped you get to the good parts. We're really excited about our new PaaS service model. It's free to try, so check it out today. If you found this episode valuable, please subscribe and follow Cofactr as we continue to revolutionize electronic hardware.